Welcome back. Let's look at some example problems involving basic 3D formulas. Alright, so for our first example, we want to find the distance between the points -2, 7, -9, and 3, -1, 0. Alright, so now if we want to calculate the distance between 2 points in the 3D coordinate system, what we need to do is use the distance formula in 3D. And so here's what that formula looks like. If we have 2 points, P1 and P2, the distance between points 1 and point 2 is equal to the square root of the difference in the x-coordinate squared plus the difference in the y-coordinate squared plus the difference in the z-coordinate squared. All right, it's the same thing as the distance formula in 2D, except we now also take into account the z-coordinates of our 2 points. Okay, so if we want to calculate the distance between these 2 points that have an x, y, and z coordinate, here's what we'll have. The distance will be equal to the square root of the difference in the x-coordinates squared. So if we go to our points here, we have 3 and -2. So we'll have 3 minus -2. And then we'll add that to the difference in the y-coordinates squared. And so our y-coordinates are -1 and 7. So we'll have -1 minus 7. And then that will be added to the difference in our z-coordinates squared. And don't forget that we're still under the square root here, but our z-coordinates are 0 and -9, so we'll have 0 minus -9. All right, now if we simplify, the distance is equal to the square root of 3 minus -2 squared. 3 minus -2 is the same as 3 plus 2, so that's 5. So we'll have 5 squared, and then we're adding that to -1 minus 7 squared. -1 minus 7 is -8, so we have -8 squared, and then we're adding that to 0 minus -9 squared. 0 minus -9 is the same as 0 plus 9, so we have 9 squared. Okay, now if we simplify further, this is equal to the square root of 25 plus 64 plus 81, right? 5 squared is 25, -8 squared is 64, and 9 squared is 81. 25 plus 64 plus 81 is 170, and so this is equal to the square root of 170. And 170 doesn't have any perfect squares as a factor, so we can't simplify this any further, which means that the square root of 170 is the distance between these 2 points in 3D space. Okay, let's take a look at another example. All right, so next up we want to find the lengths of the sides of the triangle with vertices -1, 0, -2, -1, 5, 2, and -3, -1, 1, and then determine if the triangle is a right triangle, an isosceles triangle, or neither. All right, so this problem is a little bit involved, but once you understand what it's asking you, it's really not too bad. And so let's dissect this problem. Let's see what they're asking us to do. We want to find the lengths of the sides of the triangle with these 3 vertices, and the vertices are described by 3-dimensional points. We have an x-coordinate, a y-coordinate, and a z-coordinate for all 3 of these points. So if we're trying to find the lengths of the sides of the triangle, which are going to be located between these vertices or these points, what we're really being asked to find here is the distance between those points. All right, and we can do that using the distance formula that we just used in the previous example. And so in case you forgot, this is what it looks like. The distance formula in 3D looks like this. The distance between 2 points, P1 and P2, is equal to the square root of the difference of the x-coordinate squared plus the difference in the y-coordinate squared plus the difference in the z-coordinate squared. All right, so let's label each of these points here, and then let's work on calculating the distance between each of them. So I'm going to say that this is point A, this is point B, and this is point C. If we want to find the distance between point A and point B, here's what that will be equal to. We'll have the square root of the difference in the x-coordinates. So we'll have -1 minus -1, -1 minus -1, and that will be squared. And we'll add that to the difference in the y-coordinates, and that will also be squared. Our y-coordinates are 5 and 0, so we'll have 5 minus 0. And then we want to add that to the difference in the z-coordinates and square that as well. And our z-coordinates are 2 and -2, so we'll have 2 minus -2. All right, if we simplify, and I'm going to do a couple steps at once here, we know that -1 minus -1 is the same as -1 plus 1. Those negatives cancel out, so we have -1 plus 1. That's 0, and 0 squared is 0. So we have the square root of 0 plus 5 minus 0 squared, which is just going to be 5 squared, which we know is 25. So we have 25 plus 2 minus a negative 2, which is the same as 2 plus 2, which is 4. And then 4 squared is 16, so we're adding 16. Now 25 plus 16 is 41, and so this just becomes the square root of 41. So I'll write that as such. Okay, so that's the length of the side of the triangle between points A and B. Now let's look at the other two sides. Let's find the distance between point A and point C. That's going to be equal to the square root of the difference in the x-coordinates. And so we have -3 and -1. So we'll have -3 minus -1 squared plus the difference in the y-coordinates, and that will be squared as well. And we have -1 as this y-coordinate, and then 0. So we have -1 minus 0 squared plus the difference in the z-coordinates. So we have 1 and then -2. So we have 1 minus -2 squared. And if we simplify, -3 minus -1 is the same as -3 plus 1. So that's -2. And -2 squared is 4. So this is equal to the square root of 4 plus -1 minus 0 squared. -1 minus 0 is -1. Square -1, you get +1. So we're adding 1. And then 1 minus -2 is the same as 1 plus 2, which is 3. And 3 squared is 9. So we'll add 9. All right, 4 plus 1 is 5, plus 9 is 14. So this just becomes the square root of 14. And so I'll write that. We have the square root of 14 as the length between points A and C. All right, now we have one more side length to calculate. We have the lengths for 2 of the sides of our triangle. We now need to do one more. We need to know the length of the side between points B and C. So let's find the distance between points B and C, and that's going to be equal to the square root of the difference in the x-coordinate squared plus the difference in the y-coordinate squared plus the difference in the z-coordinate squared. Now our x-coordinates are -3 and -1, so we have -3 minus -1. Then our y-coordinates are -1 and 5, so we have -1 minus 5. And then the z-coordinates, we have 1 and 2, so we have 1 minus 2. This will be equal to the square root of -3 minus -1 squared. -3 minus -1 is the same as -3 plus 1, so that's -2. -2 squared is 4, so we have 4 plus -1 minus 5 squared. -1 minus 5 is -6, and -6 squared is 36. So we have plus 36 plus 1 minus 2 squared, and 1 minus 2 is -1. -1 squared is 1. So we're adding 1. All right, now 4 plus 36 is 40, plus 1 is 41, so we have the square root of 41 for the length of this third side. And so now, notice from the lengths of our 3 sides of this triangle that 2 of them are the same, right? The length of the side from points A to point B is the square root of 41, and the length of the side from points B to point C is also the square root of 41. And so if we need to determine if the triangle here is a right triangle or an isosceles triangle, we already know what that answer is. If 2 sides of the triangle are the same, but the third side is different, then we have an isosceles triangle, right? An isosceles triangle has 2 sides that are the same length, and then the third side is a different length. All right, and so in this case, we can make the conclusion that we have an isosceles triangle. Okay, that's the answer to this example. Let's take a look at a different example. All right, so next up, we want to find the coordinates of the midpoint of the line segment joining 5, -9, 7 to -2, 3, 3. All right, so this example is going to require the use of a different formula. Remember that if we want to find the midpoint between 2 points in 2 dimensions, we use something called the midpoint formula, where we take the average of the x and y coordinates, and that gives us the midpoint. Well, we can also do that in 3D. We have a midpoint formula for points in 3 dimensions, and it looks like this. We take the average of the x-coordinates, the average of the y-coordinates, and the average of the z-coordinates, and that will make up the x, y, and z-coordinates of our midpoint. All right, so this is fairly simple. Let's calculate the midpoint here. It'll look like this. We'll take the average of our x-coordinates, so we'll add 5 and -2, 5 plus -2, and then we'll divide that by 2. then we'll average our y coordinates. So we'll have -9 plus 3 divided by 2. So we'll have -9 plus 3 divided by 2. And then we'll average the z coordinates. So we'll have 7 plus 3 divided by 2. 7 plus 3 divided by 2. Okay, now if we simplify, this will be equal to 5 plus -2 divided by 2. 5 plus -2 is 3, divided by 2 is just 3 halves, so we'll leave it like that. Then we have -9 plus 3, which is -6, divided by 2. That gives us -3. And then 7 plus 3 is 10, divided by 2 is 5. So our z-coordinate is 5. And so 3 halves, -3, 5, is the midpoint of the line segment joining these 2 points together. All right, finding a midpoint is really just that simple. You average up the x-coordinates, you average up the y-coordinates, and you average up the z-coordinates. Let's take a look at a different example. Okay, so next up we want to find the standard equation of the sphere with a center 5, -1, 1, and a radius of 7. All right, now if you watched the lesson video for this topic, you were probably familiar with the distance formula and midpoint formula in 3D, but another formula that I went over was the standard equation of a sphere. And the reason we looked at it is because it is an extension of the standard equation of a circle in 2D. And so if you remember, the standard equation for a circle was x minus some value h squared plus y minus some value k squared, and that's equal to the radius of the circle squared, right? This is the standard equation of a circle where h is the x-coordinate of the center of the circle and k is the y-coordinate of the center of the circle. And so what we do to get the equation of a sphere in a 3D coordinate system is we extend this equation to include the z-coordinate that would be the center of the sphere. All right, and so that looks like this. The standard equation of a sphere is x minus h squared plus y minus k squared plus z minus l squared is equal to r squared, where r is the radius, and HKL makes up the point that is the center of the sphere. So L is the z-coordinate of the point that is the center of the sphere. All right, so if we want to find the standard equation of the sphere with a center of this point and a radius of 7, setting up that standard equation should be pretty simple. We'll start by writing x minus h, which is the x-coordinate of the center, which is 5. So we'll have x minus 5, and we'll square that. Then we'll add that to y minus the y-coordinate of the center, which is -1. So we have -1, square that, and we'll add that to z minus the z-coordinate that is the center of our sphere, which is 1. So we'll have z minus 1 squared, and that will be equal to the radius squared, which is 7. So we'll have 7 squared. Okay, and so if you wanted to, you could leave it in this form. This would be the standard equation of the sphere in this case, with this center and this radius, but typically it's a good idea to simplify anything if you can. In this case, we know that y minus -1 is the same as y plus 1, and we know that 7 squared is 49. So let's write this again. We'll have x minus 5 squared plus y plus 1 squared plus z minus 1 squared, and that's equal to 49. All right, and so that is the standard equation of the sphere with a center of 5, -1, 1, and a radius of 7. Let's take a look at one more example for this video. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful and you want access to more content such as exclusive bonus videos and dark mode versions of my videos, I'd invite you to check out my membership site, JK Math Plus, where all of that content is available. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the video and take a look at the next example. All right, so here's our last example. We want to find the standard equation of a sphere where point A, which is located at 10, 4, 3, and point B, which is located at -1, 2, 7, are at opposite ends of the diameter. All right, so this one's a little bit tricky, but it's nothing that we can't handle. In order to figure out what exactly we're doing here, I think we should draw a little sketch of a sphere. And so I'm going to start by just drawing a perfect circle here, and just imagine that this is a sphere of some kind. I'm trying to make this look like a sphere as much as possible with these extra curved lines. But regardless, this is a sphere. And if we have 2 points that are at opposite ends of the diameter, here's what that means. Remember that the diameter of a circle is the distance across a circle from one point to another. That's the same thing for a sphere. The diameter of a sphere is the distance from one point directly across to another. And so what I'm going to do here is not going to be an accurate drawing at all in terms of where these points would actually be in a 3D coordinate system, but essentially what we're being told here is that point A would be here and point B would be here. Again, they could be anywhere around the sphere, but the point is the distance from point A to point B will be the diameter of the sphere. All right, it's the distance directly from one side of the sphere to the other. And so why is this information important? Why do we even care that we have this information in this problem? Well, if we want to find the standard equation of this sphere, remember that we need to know the radius of our sphere in order to set up that standard equation, right? We used that standard equation in the previous example. It looks like this. We have x minus the x coordinate from the center point squared plus y minus the y coordinate of the center point squared plus z minus the z-coordinate of the center point squared, and that's equal to the radius squared. All right, and so looking at this standard equation, there are some things that we need here that we currently don't have. We don't know what the coordinates are of the point that is the center of our sphere, and we don't know the radius. And so how can we determine these two things using these 2 points? Well, let's start with the center point. How can we find the point in the middle of our sphere? Well, if you think about it, if we know 2 points that are on opposite ends of the diameter, what that means is if we draw a line from one point to the other, that diameter, that line, is going to cross through the center of the sphere. In other words, it's going to cross directly through that center point, which would be the midpoint between points A and B. So we can use our midpoint formula for 3D points to find the center of our sphere. So let's do that first. And remember, the midpoint formula looks like this. We just take the average of our x-coordinates, our y-coordinates, and our z-coordinates for these 2 points. So our center, or the midpoint, will be at the point where we average our x-coordinates. So we'll have -1 plus 10 divided by 2. So I'll write -1 plus 10 divided by 2. And then we'll have the average of our y-coordinates, which are 2 and 4. So we'll have 2 plus 4 divided by 2. And then we'll average our z-coordinates, which are 7 and 3. So we'll have 7 plus 3 divided by 2. Now if we simplify, we have -1 plus 10, which is 9, divided by 2. That gives us 9 halves. And then we have 2 plus 4, which is 6, divided by 2, which is 3. So we'll have 3. And then we have 7 plus 3, which is 10, divided by 2, which is 5. So now we have the point that is the center of our sphere. So that's going to help us set up this equation, the standard equation of our sphere, but we're still missing the radius of the sphere. And so how are we going to find that radius? Well, we're going to make use of another formula that we already used in this video as well. Remember that the radius is a measurement of half the diameter, right? The diameter is a distance across the sphere from one point to another, but the radius is the distance from the outside of the sphere to the center of the sphere. So it's half of the distance of the diameter. So what we can do here is calculate the distance between point A and point B, which would be the diameter, and divide it by 2. That will give us the radius of the sphere. Another thing that we could do is calculate the distance between either point A and point B and the midpoint, but since the midpoint has a fraction as the x-coordinate, that's a little tricky and I don't want to work with that. And so let's just find the distance between points A and B and divide it by 2. Okay, and so if you don't remember, here's what the distance formula looks like. We'll take the square root of the difference of the x-coordinate squared plus the difference in the y-coordinate squared plus the difference in the z-coordinate squared. So our radius is going to be equal to 1/2 of the distance between point A and point B. And so that's going to be equal to 1/2 times the square root of the difference in our x-coordinate squared. And so we'll have -1 minus 10, all right, -1 minus 10 squared. Then we'll add that to the difference in the y-coordinates and add that to the difference in the z-coordinates. And both of those differences are squared. All right, so for the y-coordinates, we have 2 and 4. So we'll have 2 minus 4. And then for the z-coordinates, we have 7 and 3. So we'll have 7 minus 3. Now if we simplify, this will be equal to 1/2 times the square root of -1 minus 10. That's -11. And -11 squared is 121. So we'll have 121 plus 2 minus 4, which is -2. -2 squared is 4. So we have 121 plus 4, and then we're adding that to 7 minus 3 squared. 7 minus 3 is 4. 4 squared is 16. So we'll have 16. All right, now 4 plus 16 is 20, plus 121 is 141. So this is equal to 1/2 times the square root of 141. Or another way that we could write that is the square root of 141 divided by 2. That is the radius of our sphere. And so if I remove these two formulas here, we can set up the standard equation of this sphere where these 2 points are at opposite ends of the diameter. All right, because 9/2 is our value of h. It's the x-coordinate of the center point of the sphere. 3 is our value of k. It's the y-coordinate of the center. And 5 is L, the z-coordinate of the center. So here's what we'll have. We'll have x minus 9/2, and that's squared, plus y minus 3, and that's squared, plus z minus 5 squared, and that's going to be equal to the radius squared, but I need to make some space. Remember, the radius is right down here. The radius is equal to that value of the square root of 141 divided by 2. So we'll have the square root of 141 divided by 2 squared. All right, now the only thing we need to simplify here is the radius. If we want to, you could leave it in this form if you wanted, but if you square the square root of 141, you just get 141, and then squaring 2 will give you 4. So if you want, you can rewrite this to just be 141 divided by 4, and that would be the same thing. Okay, but either way, this is the standard equation of the sphere where points A and B are at opposite ends of the diameter. All right, so this is a pretty nice example to end on. It used all 3 of those formulas that we looked at in the video, of the distance formula, midpoint formula, and the standard equation of a sphere when we're working in a 3-dimensional coordinate system. Okay, and so with that, that's it for this video. If you want to see some more examples, I do have more available on my membership site, so feel free to look into becoming a member if that interests you. If you have any questions, feel free to leave those in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.